This is a talk about Arduino USB game controller. It's based upon the Arduino Mikro microcontroller, and this is a really easy thing to do. Or is it? I'm going to talk about the necessary stuff you need to have, like components, the tooling, and some optional tools. The circuit layout in EagleCad, and preparation for milling the circuit. I'm going to just touch that topic and some code. If there's any questions, just put a hand in there and ask. The gear necessary for the project is the MCU, a microcontroller, some electronic components like buttons and resistors, and a copper board, either a proto board or a FR2 copper clad. And if you have one nearby, a milling machine, that's the one we have at the university stand, is good to have. Yeah. This little thing, the Arduino Mikro, uses an Atmega 32U4. It's a really nice little microprocessor which enables USB. That's the trick. The other options is the microchip MK20DX 128 or 256. They both have USB on board. The nice thing about this card is the form factor. It's really small. It has above 30 inputs, and it's fast and reliable. And it has all the things you want to in a microcontroller, as well as USB. So it's nice and powerful compared to the size. And if we go to see this one, come on. Okay. No. It's always hard to do this on two screens. Okay, that didn't work, but we can do the next slide. This has the layout of the inputs of this chip, this card. It's kind of important because here we see what's power, what's ground, what's input, outputs of the card. We are only going to care about the ground and some inputs. So let's put up Eagle and show you guys what that is. If you know our, okay, Eagle, come on. No. Come on, there you go. Yay. This is Eagle. Let's take the other card as well. This is Eagle as well. It's really hard to do on two screens. And here we go, the last window. So I prepared some of the card before I started this talk. And this is the just pin headers and a net wire for telling me where these inputs are going to be. So I marked the different inputs as the same as the schematic here. So we have MOSI and chip select and RX and TX, reset ground, that's the important part now, and the input output row, 13 of those, and the analog inputs, and ground and V in. So the important parts are these ones. I'm going to use this and nothing more. Oh. So let's add a button. Search up a switch, and we're going to use okay. The searching in EagleCad isn't that great, so let's just do it. Button. Let's find this button. Momentary. This is a really standard little switch. It's the same as the one on here. It's black. It's not great hardware, but it's okay. It works. It's a tactile switch, which means it's momentary and tactile, which means it's you feel it when you press it, and it's a dome switch. So they noise a little bit, but they work. So that's why, and they are really cheap. So we're going to place some of those. And as you see on this, it's only 2 inputs. So it's going to be some of them here. And the placing isn't that important in the... So 4 and 4. So then I'm going to replace the routing for these switches. And just do it randomly. Oh, yeah. So, oh, come on. So I'm going to make this net complete, and then it's the hard part. So then it's ground, and we are done. I could use these labels, but it's more fun to do it this way. Come on. So, routing complete. Huh? Okay. Any questions? No, it's all the buttons are connected. This is next thing we're going to do is make the layout. So, as I said, this is time-consuming but not hard. Here's the planning starts. Here's where the planning starts. First of all, the layout, the schematic is the right way around. Like it's not mirrored. If you're going to emboss this on a thing, you are going to get a mirror of this. So if I'm going to mill this, I need to mirror it. I need to turn it around and show it from the other side. So if you forget this, all the pins are going to be in the wrong place. And your solder is going to be really hard. Your solder job. So because all the net is the right way around, we need to mirror this one. Then we're going to just select the whole thing. And EagleCad is kind of old school. You have all these buttons, and different buttons have different functions. Like we have a special button for selecting. And if you're going to move a group, you're going to select move group and stuff like that. So this is kind of hard to get used to, but it's okay when you're into it. So that's wrong. Come on. Here we have the select tool, and select all thing, and the move tool. No, the mirror tool, and mirror group. Oh, come on. Move group. Because it's a free version, this have some limitations among the size of the layout. So that's why I got this error message. But now I can mirror it. Oh, no, I can't. Okay. select only this one then. This is the important part, so just hey, here we go. So just move this in place. Here. So now we're going to lay out where we want the buttons. Because of this, we know the size. We can kind of go with the flow and use the size as measurement for where we want to place these buttons. So if this is in the middle, one side of the gamepad could be some buttons. So if I just move this one, I can place it here. I think I lost a connection. And the orientation of these buttons is the same as anyway. So the only thing I needed to think about is how many wires that cross each other. Because as this is a free version, I have a limitation of how many layers I can place. I have only the top layer and the bottom layer. So this isn't the top one, and I just need to find them. Which is the top one? This is maybe the top one. No. Oh. Here we go. If this is the top one, I can place it here, and I can place the next button with the next connection below that. And orient it that way it's easy to connect. Okay, and then I'm going to place these on the other side. My neck is going to break. Yeah. Then we're going to place you here. And use the select tool once more. And this is going to can use quite a lot of time of placing, but let's just move. Oh, come on. So move this one as well a little closer. And place these buttons in a neat way. There's one button, S8, that's not connected. So I need to go back to the schematic and see what's wrong with it. And S8 is the top one. Then we're just going to try to connect it. And our route. There we go. Board. And then S8 is connected as well. So let's make the routing for this. EagleCad has an auto router. It's not great in anyways. It works, but it's not great. The good way is to do this manually, and it's not hard at all. So just pick the routing tool and start drawing lines. The lines will get highlighted, so it really shouldn't be any problem. I picked this on the inside because it's some of the wires that need to be crossing it. And the same with this one. Okay. And then we have the last to the ground, and we're just going to pick the last place to put it. It's one side finish. I know the sizing of the route isn't great, but I don't need any ground plane for doing this. The noise in the buttons are quite significant anyways. So, and we are not going to use any noise protection anyways, other than the chip in itself. So now it's doing the same thing on the other side. I can show you that as well. Are you with me? It's not that. Huh? Okay, we're going to use auto router just for the kicks of it. And since we shouldn't be having a bottom layer, a top layer should be enough. And we are going to continue. And start. Yay. It's but ugly, but it's worked. It has done its job. Oh. Probably, if we are going to export this and mill it, it wouldn't work. This is because of the tolerances of the milling bit and the size of where I'm going to put what I'm going to cut away. So I probably wouldn't route this on electronic router, but it's finished in a way. Next part, let's go. Hey. Yeah, so we did a really simple schematic and a really simple layout. And the next thing is the coding of this thing. And there is a warning to do this. If you do a mistake and you start this by sending a character to your computer, it will keep on sending that character when it gets turned on. So there's either you should have a way to control that with your software, or you can do this in hardware by adding one more button or a switch that powers the pins, the pins in itself. Yeah, so we could just add one more button in Eagle. And that pin could be connected to the reset pin. So if you hold this button in, you could hold it in while you type something to reset this. I could show you a way to do it if we get the time. Yeah. the main part of the code is this. Okay, it's almost impossible to read, but let's just. Isn't there any way to make the font larger? Yep. It uses a library that's the keyboard age library, which is possible to use with the Arduino Mikro and the Arduino Duo and Duomino and other cards which uses the Atmega 32U chip. But it's really simple. It's only keyboard sending device, so it starts the keyboard process by keyboard begin, and you initialize your buttons or your inputs, and you read the button state. So the thing I'm going to do now is if I press the button, it's going to write an A. Let's do, some A's. And if you there's a couple of ways to debounce this and make it write less than 1A, but it's not that hard, and then it's standard code for debouncing a button. So just find the code. Here we go. This is only debouncing by looking at the previous state of the button, so it should be easier to handle one button press at once. Now I'm going to do the same thing, but now it's going to write significantly less signs, and it's at number 3. So now it works. I should have had a working prototype with the card, but it didn't work. So, but I have this as a mock-up. It's the same, sort of. I can just do the jiggle with it, so, and connect up more buttons. No, that's not right. So, yeah. So now it's just going to be the repetition of the same code. And when this is done, I could use this to connect to the mobile phone as well as a computer, because most of the games that we play on the mobile phone uses a key press for actions. So just find that key press and you can use Arduino Mikro to control a game on your cell phone. You need an USB on the go cable, but most people have that. So that's one application for this. And if you extend it with a wireless module or a Bluetooth or BLE module, you can have a really good one. Of course, with the battery, you have the opportunities are endless. So that's the super easy Arduino microcontroller for game control, I mean. And is there any questions? Okay. No. Okay. Yeah. Mouse control. Yeah. Of course, it's possible to use the same. The question was, is it possible to use this as mouse? Yes, it is. You have a library called mouse.h, a header file for that, and it uses the same principle. So if you connect your Arduino Micro or similar card to a computer without doing the right things, we will take over your mouse. That's even worse than taking over your keyboard in many ways, especially if you are clicking. If you are starting to click things with this one, you could have a really hard time. So be certain that you have software that can take activates the mouse functionality before you use that. I have done it once, and it was kind of hell. Yeah, more questions? Okay, thank you.